So just a couple of slides on thunder. Thunder is so cool though. I haven't probably emphasized how much I like storms, as long as I'm not too afraid of there being tornadoes. And I like the lightning. I like to watch the lightning as long as I'm being safe indoors, I suppose. And I like to hear the thunder. So thunder actually is the sound part of lightning. Now, the deal is that I'll talk in a minute that light travels faster than sound. So we see the lightning bolt before we hear the thunder. But before I do, just to kind of remind you, the reason we see the lightning is the same reason we see the thunder. The flow of electrons create a lot of heat, and that heat we see in the form of lightning. And actually what the heat does is to expand the air. Like if you're a visual person, here's my lightning bolt. Okay, a flow of electrons. You remember it could be actually kind of a back and forth sort of thing. And if we look at the air around it, it gets really hot, and hot air will expand. And actually it expands faster than the speed of sound. So it breaks the sound barrier in its motion. And so actually that boom you hear is a sonic boom. Isn't that cool? And how hot does it get? Well, 5 times the surface, not the interior part of the sun, 5 times the surface of the sun. So that creates a shock wave that actually then, like I said, is moving faster than the speed of sound, and we hear it boom. Now, light, we'll see the light before we will hear the thunder, all right? And as some of you know, the closer the lightning is to us, the shorter that delay. So you might have heard it differently, but I kind of looked at different sources and I came up with the rule of 5. So the deal is if you count the seconds between you see the lightning, because light travels faster than sound through air, and then you hear the thunder. And for instance, if it's 10 seconds between seeing the lightning and hearing the thunder, you divide 10 by 5 and you get 2. And it's 2 miles is the distance between you and that lightning bolt. So if then, for instance, you hear there's only like a 2-second delay between you see the lightning and you hear the thunder, then that means that that lightning bolt is less than a half of a mile away. If you basically see it and hear it at the same time, then it's right on top of you. Okay. Talk about some kind of different, I won't say types of lightning, but if you've ever heard of heat lightning, and I bet you've seen heat lightning before, it's that type of lightning that's kind of clear off in the distance, and a lot of times it's kind of a muggy sort of day, and you don't hear it. Okay, you never do hear it. It just kind of rumbles, or no, I shouldn't say rumbles. It just kind of illuminates the sky. It's a lot of sheet lightning far away. Well, what's happening basically is that's normal lightning that is too far away for the sound to make it to you. So the sound basically runs out of energy or dissipates as it is on its way to you. So that's heat lightning. Oh, and by the way, sometimes students will say, well, why do they call it heat lightning? And I think it's because basically when you're observing it, it's probably kind of a muggy sort of moist, sort of hot sort of weather. And you may have heard this phenomenon or felt this phenomenon, encountered it. This phenomenon, when you hear lightning, sometimes you hear it as a like a clap, and the other times you hear it as a boom, 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 kind of a rolling sort of sound. So thunder, actually what's happening with the clap is that there's not much bouncing around of that sound wave before it hits you. So there's a good chance that if it's a clap, it's kind of close. The rolling thunder, boom, boom, basically what's happening is that sound is kind of bouncing around, has quite a bit of space to bounce around before it gets to you. So I bet you've run into those before too.